All right. Today we're going to take a look at an introduction to fractions. Yay! So just kind of a definition, a fraction is a number that represents a part of the whole. The whole is basically thought of as a value of 1, and the fraction represents some portion of it. In the picture below, the circle is the whole, and 3 is the part, or the numerator, and 5 is the type of part, or the denominator. We split that circle into 5 pieces. 3 of them are shaded, 3/5. So we'll talk about 4 basic types of fractions. You don't need to memorize these types, but you will see them throughout the rest of this unit. The unity is where the numerator and the denominator are equal. For example, 4/4 would be the fraction the way it's written as a picture, and a lot of times we use circles for our picture because you can split those pretty easily into a lot of different ways. So this would be 4 pieces, all 4 pieces shaded. We get a value of 1. A proper fraction, where the numerator is less than the denominator, so this n is the numerator, and the d is the denominator. So 3/4. Again, 4 pieces, only 3 of them are shaded. If we have a proper fraction, its value is less than 1. An improper fraction is where the numerator is greater than the denominator. So 9/4, you can see our circles here, each one divided into 4 pieces because that's what the denominator tells us. And 9 of those pieces are shaded in. An improper fraction has a value that's greater than 1. The last type of fraction we'll talk about is a mixed number, which has a whole number part and a fraction part. And that fraction is going to be a proper fraction. So 2 1/4, we have 2 whole, and then our third piece is split into 4 parts, and we shade one of them. A mixed number is also greater than 1. So there are advantages and disadvantages to mixed numbers and improper fractions. We'll take a look at that a little bit. The last 2 fractions take up the same amount of space. They were both 2 whole circles and then one of the 4 sections of the third circle. This means they have the same value. More interestingly, for every improper fraction or whole number, there is an equivalent representation as the other. For instance, 3 2/3. Each of the wholes would represent 3 parts. So the whole number part is 3 because there would be 3 parts to this one, plus another 3 parts, plus another 3 parts, plus the 2 that are shaded in the 4th circle, which is the same as 3 times 3 plus 2, or 11/3. So for an improper fraction, you take the whole number part times the denominator and add the numerator. 3 times 3 plus 2, and the denominator stays the same as it was. Again, order of operations, we would have to do the multiplication first and then the addition. So here the main operation or essential operation is times, that's multiplication. Going the other way, if I have these circles split into 5 pieces and I color all 5 in the first 2 circles and 3 of the 5 in the third circle, I have 13 separate pieces that are colored in of the 5 that the circle is split into. So 15 fifth parts to begin with. Each time we get 5, we fill a hole. We can do that twice for 2 holes, or our whole number will be 2, and then there are 3 left over. So 13 over 5 is 2 3/5. The essential operation here is divide. We're actually taking 5, dividing it into 13. 5 goes into 13 twice. 2 times 5 is 10. Subtract. Bring the 3 down. This is our new numerator. This is our denominator. And this is our whole number part. 2 3/5. It's just another way of thinking about a remainder, writing it as a fraction of the whole. Let's take a look at 2 more complicated examples that would be much harder to describe as a picture. So 6 2/9. We could draw 7 circles and divide the first, all 7 of them into 9 pieces, shade in the first 6 and 2 pieces of the 7th one. That would take a lot of work. If we use the math like we looked at, we would take 6 times 9 for 54. And then we add the numerator 2. So 54 plus 2 is 56. We get 56 over 9. Likewise, we could take an improper fraction, 47 over 8, and divide. 47 divided by 8, remember that's 8 into 47. Goes 5 times. 5 times 8 is 40. Subtract. We have a remainder of 7. So again, our whole number part 5 and 7/8. So here, a couple of examples to take a look at and try on your own. We have the first 2 are improper fractions. We want to make them into mixed numbers. The last 2 are already mixed numbers. We want to convert them back into improper fractions. Go ahead and take a little bit of time, see how you do with those, and then I'll put the answers up in a minute. The first 2 being improper fractions, we're going to divide to turn them into mixed numbers. We let the denominator divide into the numerator. 4 goes into 11 twice. 2 times 4 is 8. Subtract. So our mixed number would be 2 3/4. Always kind of fun when you use consecutive numbers, 2, 3, 4 there. The next one, a little more difficult, 32 into 73. So one possible way to attempt to do these is to estimate, right? Just look at the tens place, look at the 3 and the 7. How many times would 3 go into 7? It would go in twice. So let's see if 32 goes into 73 twice. And if I multiply, 2 times 2 is 4, 2 times 3 is 6, subtract. We get 9, which is less than 32, which means that is the most that we could divide by, or divide into. So we get 2 and 9 over 32. Again, a little more difficult because 32 in the denominator. You could, again, if you wanted, draw some circles. You have to start with the first one, divide it into 32 pieces, which would be a little bit more difficult. Color all those pieces in, then go to the next one, make the 32 pieces, color those all in, then a third circle, you divide it into 32, you'd only have 9 pieces left that you would color in. It's a little more time consuming than doing the division process. Next, we're going to go from a mixed number to an improper fraction. So we're going to take 3 times 8, whole number times the denominator, and then add the numerator. And again, our answer will be put over 8. So 3 times 8 is 24. That means for the 3 whole, we could split that into 24 pieces of 8. (24 plus 1 is 25 over 8. Same process with the fourth one here. We're going to take 5 times 16 plus 7 all over 16. 5 times 16. Well, if you're not sure 5 times 16, do that over here. 5 times 6 is 30. 0, carry the 3. 5 times 1 is 5, plus 3 is 8. So 5 times 16 is 80, plus 7 over 16, or 87 over 16. So just being able to convert from one form to the other is going to be a big part of this first lesson. The other thing that's going to be a big part of this lesson is writing equivalent fractions. So proper fractions can be represented multiple ways. For instance, this first circle has 2 of its 3 pieces colored in, so that would represent 2/3. If I take each piece and divide it again, now I have 4 pieces that are shaded in blue, and 6 total, so 4 over 6. But notice I haven't colored in any more than I had on my first picture. I could go back to that 2/3 and take each of the 3 sections and divide it into 5 sections. So now I have 15 total pieces and 10 that are shaded in for 10 over 15. All of those are equivalent. They all represent the same portion, just written a different way. Another way to think about it, we know it's true because in each case, you think that you're multiplying the top and the bottom by the same number, which is the same as multiplying by 1. So remember that a over a number divided by itself is 1, as long as a is not 0. And a times 1 is a. So in that way, we can form equivalent fractions. Take a fraction that's maybe a proper fraction that's in its reduced form, doesn't have to be, multiply by a number over itself, so 3 over 3. 3 divided by 3 is 1, so we're really just multiplying by 1. With fractions, we multiply straight across. 3 times 1 is 3, 4 times 3 is 12. Likewise, we could take 2/3, multiply by 6 over 6. 2 times 6 is 12. 3 times 6 is 18. And 2/5, multiply by 2 over 2. We get 2 times 2 is 4. 5 times 2 is 10. This method of finding equivalent fractions is going to become important when we do addition and subtraction of fractions. In recognizing this relationship, it probably becomes clear that there's always a simplest way to represent any proper fraction. It's actually called simplest form. I call it reduced form. It means expressing a fraction with the smallest possible integers. Say there's a fraction 8 over 12. Both the numerator and denominator can be divided by the same whole number. They're both divisible by 4. If we divide the top and the bottom by 4, again, that's the same as dividing by 1, we would get 2/3. This is called reducing. Here are a couple more examples. 12 over 42. Both numbers are divisible by 6. So I take 12 divided by 6 is 2. 42 divided by 6 is 3. So 12 over 42 is the same as 2 over 3. 18 over 32. Both numbers are divisible by 2. Take 18 divided by 2, get 9. 32 divided by 2 is 16. So 9 over 16 and 18 over 32, equivalent fractions. The largest whole number that you can divide from two other whole numbers is called the greatest common factor. So we're just dividing by the greatest common factor in that first example of 12 and 42. And in our second example, the greatest common factor of 18 and 32. So again, a couple of examples. And I do want to say one thing about reducing. When you reduce, if you don't pick the greatest common factor, you can always reduce a second time. So even when you think I've got it done, double check, see if you can divide by something else. So for these couple examples here, a fraction is given, find 3 equivalent fractions. So we have one that's in lowest terms, 2/3. We want to write 3 equivalent fractions for 2/3. The last 3, we want to reduce. So we have a fraction that's not in lowest terms or simplest form. We want to get it so that it is in simplest form. Again, I'm going to give you a minute or two to work through that, and then we'll take a look at answers. So for example 1, if I multiply by 2 over 2, 2 times 2 is 4, 3 times 2 is 6. So 4 over 6 is equivalent to 2/3. Now, when I go to do the second equivalent fraction, I'm going to go back to my 2/3. I'm always going to go back there because it's got our smallest integers to work with. And if you're going to write three equivalent fractions, I would choose to multiply by 2 over 2, 3 over 3, and 4 over 4. You don't have to. There are an infinite number of possibilities. But if I go 2 over 2, 3 over 3, 4 over 4, that will always give me kind of some small numbers easier to work with. So if I take 2/3 times 3 over 3, 2 times 3 is 6, 3 times 3 is 9. And then again, 2/3 times 4 over 4, 2 times 4, 8, 3 times 4, 12. All of those fractions are equivalent. Reducing, this one's a little bit, can be a little bit more difficult. Trying to find a number that evenly divides into both 26 and 39. They are both divisible by 13. (26) divided by 13 is 2. 39 divided by 13 is 3. 49 and over 56. So one option, remember we have that multiplication table in our packet. Find in either a row or a column, try to find your numerator and denominator. So the 49 and the 56 are in row 7 or in column 7, depending upon which way you read it. And the nice thing is that means both numbers are divisible by 7. So if you're looking at row 7, you then go to the top from 49 and see, well, 49 is 7 times 7. 56 is 8 times 7. So it reduces to 7/8. Using the table wouldn't have worked for 26 over 39 because it only goes up to 12s. And that's a 13. So unfortunately, there's not really a shorthand way to do that one. 70 over 112. I notice they're both even, so that's where I'm going to start. And I'm going to divide by 2. I guess I can write in here, I divided these by 7. 70 divided by 2, that's 35. 112 divided by 2 is 56. These I could look again at the table and see. And these also are both divisible by 7. So technically, the greatest common factor, I could have divided everything by 14 to begin with. 35 divided by 5 is 35 divided by 7 is 5. 56 divided by 7 is 8. We'll get 5/8 for our reduced fraction. So there we have the lesson for today. Complete your assignment, and we will check yesterday's assignment and today's assignment on Monday. Have a great rest of your Monday. And like I said, the great rest of your Friday. I will see you on Monday. Enjoy any of the homecoming festivities that you choose to partake in the rest of this weekend.